This is page 2, or the back of page 1 rather. So sometimes when we're dealing with logarithms, we have to know how to apply the properties of logarithms in order to solve. So this first section, number 5 here, I'm asking you to expand. So really you're just applying the properties. So what I notice on this one is this is division. So if I want to separate this out, I'm going to write log of 2x cubed minus log of x plus 3. So division gets undone by subtraction when we're dealing with properties of logs. This part's good, but this part I can still simplify. If I have log of two things being multiplied together, I can separate that with addition. So log of 2 plus log of x cubed minus log of x plus 3. And then I'm going to apply the power property, which says that if I have a power, I can make it the coefficient. So it would be log 2 plus 3 log x minus log x plus 3. So this one was a common log. It had log base 10, and we didn't have to write it. This one's not the common log. This one's called the natural log. So I'm going to separate multiplication by using addition. So natural log of 3 plus natural log of x to the 4th. And then I'm going to apply the power property. So I have natural log 3 plus 4 natural log x. So that is expanding. The next one is a review of finding the inverse of a function. And if you'll remember, an inverse of a function has two different things. First of all, every point on the graph, like for instance if this was the point 2, 1, its inverse would have the point 1, 2. So it's a switching of x and y. The other thing that happens is it's going to be a reflection over the line y equals x. So I'm going to find the inverse of this one. This already says y equals x cubed plus 4. So if I want to find the inverse, I'm going to switch x and y. And then I'm going to solve for y. So I'll start by subtracting 4. And then to get y by itself, I'm going to cube root both sides. So y equals the cube root of x minus 4. Now, if this was a function, then I could write it like this. And we can tell that it's going to be a function because it would pass the vertical line test. A cube root function looks like this, and so that would pass the vertical line test. Okay, this is a function. Let's write its inverse. So right now it is y equals x plus 5 over 2. If I want to write the inverse, I'm going to switch x and y and then solve for y. So I'll start by multiplying by 2. Whoops, that should be an x, shouldn't it? 2x. And then subtract 5. So if this is a function, and it is, I can write it as a function like this. This means the inverse of the function. The next part, and we haven't done this in a while, is finding the zeros of a polynomial. So the reminder of what the zeros are is a zero is something that would make this equal 0. It's also all the places where it would cross the x-axis, the roots. So if I notice here, if I want to set this equal to 0, that means x could be 0, x could be 0, or x could be 0 for each one of these. Here, 2x minus 1 could be 0. So 2x could be 1, so x could be 1/2. Notice there's a 2, so that means that thing happens twice. And then here, x could be 1. So I have 1, 2, 3, 4, 5, 6 zeros. I would say that 0 has multiplicity of 3. 1/2 has multiplicity of 2. And 1 has multiplicity of 1. Okay, let's think about this one. If I want to find the zeros, the first thing I need to do is factor. I'm going to factor this again. 2x and x. And let's see here. I think if I put a 3 here and a 5 here, minus 6 plus 5. So I could say x equals 0 is one factor. So 0 has a multiplicity of 1. This would be negative 5 halves with multiplicity of 1. And here the 0 would be 3 with multiplicity of 1. Now, multiplicity means if it has an odd multiplicity, it's going to go through the graph. But if it happens an even number of times, it's going to turn at the graph. So like, let's go over here and think about this one. If I graphed this one, I would have a 0 and a 1/2 and a 1. So in behavior of an x to the 6 means the ends are going to go up. 0 happens 3 times, so it's going to go through there. 1/2 happens twice, so it's going to touch and then come down and go back through 1. So it looks something like that. Okay, number 6, we're dealing with radicals. So this is cube root. So I'm looking for things that are cubes or happen 3 times. So I know that 64 is 4 to the 3rd power. I know that x to the 5th is x to the 3rd times x squared. And this is y to the 3rd, y to the 3rd. So since 4 happens 3 times, it's going to put a 4 on the outside. Since x cubed, that's going to put an x out here because I'm looking for cubes. I have some left over in here. And this happens once and this happens once, so it'll be y squared on the outside. Notice the next one's a multiplication problem. Since these are both square roots, I can say the square root of 32 times 27. And then I'm going to try to factor 32. 32 is 16 times 2. I'm going to leave it like that because 16 is a perfect square. And 27 is 9 times 3. The square root of 16 is 4. The square root of 9 is 3. So my answer would be 12 square root 6. The last one is addition, and you can only add if the number underneath is the same, and that's the same, the index number. So I'm going to see if I can make them the same. The cube root of 54 is 27 times 2. The cube root of 16 is 8 times 2. And the cube root of 27 is 3. And the cube root of 8 is 2. So I have 3 cube roots of 2 plus 2 cube roots of 2, which is 5 cube roots of 2. The last part deals with creating a new function from a function that exists. And the computer doesn't type the composition function very well, but it's a little open circle, and that means f of g of x. So this means that I'm going to put the g function here. The g function is x minus 2. Now this becomes the input into my f function. So I have 2 x minus 2 squared plus 4. So my new function is 2 times x minus 2 plus 4. So this is x squared minus 4x plus 4 plus 4. So let's see here, I'm going to move up here. So this is 2x squared minus 8x plus 8 plus 4. So the new function that was created was 2x squared minus 8x plus 12. Okay, look at the next one. This time we want g of f of x. So this time the input value is going to be the f function. So I'm going to have g of 2x squared plus 4. And now this is the input into the g function. So I'll have 2x squared plus 4, subtract 2. So the new function that was created is 2x squared plus 2. The last one, we're actually going to have an input value that's a number, So I'm going to start by putting negative 2 into the g function. So negative 2 minus 2 is negative 4. So this becomes negative 4. Now I'm going to go put negative 4 into the f function. So I have 2 times negative 4 squared plus 4. This is 16 times 2, which is 32, plus 4, which is 36. So that one was easier to evaluate because we knew what the number was.